Light travels at 3 times 10 to the 8th meters per second. Sound travels through air at 331 meters per second. You see a bolt of lightning strike a tall building 2.1 kilometers away. How long after the strike will you see the lightning hit the building and hear the lightning hit the building? First thing we're going to do is we're going to draw a picture. You see I already started that for you. All we need now is you. We have the building. Now we have you 2.1 kilometers away. From the building, and we have the lightning striking the building. We're going to neglect the height of the building for right now. We're not going to draw a triangle, find the hypotenuse, none of that. So, you're 2.1 kilometers away from the building. We need to write down some more given. We already know, as I just said, delta x is 2.1 kilometers. And just thinking ahead here, we have two different speeds, both in meters per second. So I'm just going to convert that right to meters. 2,100 meters. So that's your delta x. We also know the speed of light, and we know the speed of sound through air. So we have the velocity of light. That's 3 times 10 to the 8th meters per second. For those of you who really hate scientific notation, for now we will change that into a 3 with 8 zeros. Eventually you'll have to learn to just use the scientific notation, but right now we can do a 3 with 8 zeros. Don't forget your units. We also know the speed of sound. So, velocity of sound is equal to 331 meters per second. First question asks us, how long will it be after the strike until you see the lightning hit the building? When you see something, it means light has traveled from wherever you're seeing to your eyeballs. So in this case, you're going to see the lightning with your eyeballs. So the light has to travel from here to your eyeballs. So how long does it take for the light to travel from there to there? That's the first thing we're going to look for. Second thing it asks, it's real similar. How long after the strike will you hear the lightning hit the building? So when you hear something, what happens is the sound travels from whatever you're listening to your eardrums. Makes your eardrums vibrate, and then you hear things. So what we need to do is figure out how long it takes the sound to go from here to your ear. We're just going to pick one. We'll start with light because that's what it asked for first. Alright, so we know the distance, we know how fast the light is going to go. We're going to look for how long it takes the light to get there. We're just going to use our simple equation. Velocity equals displacement over time. And we're going to solve it for t. We're also going to just put our little L's in here. Okay? Because it's the velocity of light, and we're looking for the time it takes for the light to get to you. Multiply both sides by delta t, because we cannot solve for delta t while it's on the bottom of a fraction. So that goes away. Then the next step is we want to get delta t all by itself, so that we're just going to move the VL over. So we get delta t for the light is equal to delta x over VL. And we have both of those in our given. So that's going to be 2,100 divided by 300 million. If you wanted to, you could cross out the zeros to make your math a little bit easier. I did it in a calculator already. I got 0.0000007 seconds. That's not a lot of time. That's because light travels really, really fast. So practically speaking, when the lightning hits the building, you see it right away. There's no measurable difference, but now we've actually solved for that and we've proved it. So we just found delta TL, that's 0.0000007 seconds. Again, I'd rather see it in scientific notation in the future, but right now we can just leave it like that. I'm going to get rid of that, make room, and then we'll find how long it takes for the sound to get to us. This will tell us how long it takes for us to hear the lightning hit the building. We're going to use the same equation. We are going to solve it for delta T just like we did before, except now it's going to be Vs and delta Ts. Makes really no difference. We're going to move the delta T over again. Just the same algebra that we did before. We're going to move the Vs over so you get delta T equals delta X over V. And then we're going to plug in our numbers, but obviously we're going to plug in the speed of sound this time because we're solving for how long it takes you to hear the lightning hit the building. 2100 over 331 meters per second. And I did that one in a calculator earlier. I got 6.344. Delta TS equals 6.344 seconds. Get rid of that guy right there. And that's it. Problem over. If you have any comments, let me know down below. You should also be able to find my email address down there. If you're not one of my students and you're still watching this, I'd be more than happy to help you. Shoot me an email. Let me know what you think.